Jai Hind everyone. I Neeraj Sharma, Assistant Professor EC Department at Ajay Kumar Garg Engineering College, Ghaziabad. I am before you to present the video lecture for the complex topic series for the subject BEC 503 Digital Signal Processing. So, in this lecture I have chosen the topic Discrete Fourier Transform. That is the analytical concept to if we want to convert any input any sequence discrete sequence into into Z transform. So, what is it and how can we perform it? Now we will see for this. So, the discrete Fourier transform, it is for namely renowned name as a DFT. So, the DFT computes the values of the Z transform for evenly spaced points around the unit circle for a given sequence, and if the sequence is to be present is of finite duration, that has only the finite number of non-zero values, the transform used is DFT. The another its explanation, also the DFT find its application in the digital signal processing, including like filtering, correlation analysis as well as the spectrum analysis. Also, when we want to any in sequence, signal is continuous signal is given to you, and we will convert it into the discrete sequence. When we will convert it into the discrete aperiodic sequence, then when its Fourier we will find out when the Fourier nature, the transformation from Xn to time domain to the Z domain, when the output of the nature, transformation of the nature is discrete with periodic nature, then this transformation is named as a DFT. That means the in any sequence which is infinite of length, discrete sequence, when we will take its Fourier transform with discrete aperiodic sequence, then we will take its Fourier transform if the output of the Fourier transform in nature is discrete and periodic, then this transform is named as a DFT. If for the same input sequence, if the output, the transform, Fourier transform is continuous and periodic, then this transform will named as a DTFT, discrete time Fourier transform. So, this is the difference between the DFT and the DFT if we are performing the Fourier transform operation of any input sequence. So, from the definition, the let Xn be a finite duration sequence, the n point DFT of the sequence Xn is expressed by x of k is equals to summation of n is equals to 0 to n minus 1 x of n e raised to power minus of j 2 pi n k upon n, where the k is ranging from 0 to 0 1 to n minus 1. And if we want to calculate the original sequence Xn with the help of value xk, then it will be named as an IDFT, inverse discrete Fourier transform, which is evaluated by the formula x of n is equals to 1 upon n summation k is equals to 0 to n minus 1 xk e raised to power j 2 pi n k upon capital N, where the range, the output value which we want to evaluate, that is x of n. So, the sequence n is ranging from 0 1 to n minus of 1. So, this is the general theory regarding, and it is a numerical analysis how we can calculate for any sequence if it is given. So, let us say we will take an example and we will try to find out its value with the help of the numerical analysis. How we will perform, we will see now. So, here just I have taken the example that they derive the DFT for a sequence x of n is equals to value 1 1 2 2 and 3 3. and compute its corresponding amplitude and the phase spectrum. So, when we will calculate our requirement is to evaluate the DFT, that is your question which is been asked here, and the DFT for which the sequence given at that is xn, that is 1 1 2 2 and 3 3. Okay. So, first of all, that is in a sequence. We have to apply the equation. We have to calculate the value of DFT. So, first of all, note that what is the value of this n point DFT? What is the value of n? The length of the sequence is total 6 elements has been given here in the sequence. So, the length will be 6. The value of n will be 6. Now, we have to calculate the value of this DFT, which is of x of k, which is given by summation of n is equals to 0 to n minus 1 x of n e raised to power minus of j 2 pi n k upon capital N, where the k is ranging from 0, 1, 2, 3 up to n minus of 1. So, from the given data, the data which is given here, this sequence n value 6. So, the xk here, which is equals to n is equals to 0 to n minus 1, n value 6. So, it is ranging from n is equals to 0 to 5, input sequence of xn e raised to power minus of j 2 pi n k upon 6, okay, because n value is 6, or in the simplified form we can write it, it is 3. Now, that is summation of n is equals to 0 to 5 x of n e raised to power minus of j pi n k upon 3 here. So, we can now simplify it. So, now we will calculate, and the value of this k, which is ranging from 0 to n minus 1, n value 6. So, 0, 1, 2, 3, 4 and 5. So, total points where we have to calculate the value of DFT, that is from k equals to 0, 1, 2, 3, 4, 5, because of, as per the formula, k is ranging from 0 to n minus 1, n value 6. So, 6 minus 5. So, that is 0 to 5 here. So, one by one we can now calculate. So, for the value of this k is equals to 0, when we will evaluate the x of 0. So, put this value in the equation. Let us say this equation number A, let us say we will consider. So, now we will put here summation of n is equals to 0 to 5 xn e raised to power of minus of j pi n k upon 3. So, put the value here j pi n k value will be 0 here, 0 by 6. So, this particular value will become 1. So, the n is equals to 0 to 5. Now, this is of x of n. So, now we can expand it. So, after the expansion, we will get n is equals to 0, x1, then 1, then 2, x2, x3 plus x4 plus x5. So, the final value will for the x is equals to 0 will become 1 plus 1 plus 2 plus 2 plus 3 plus 3. So, we put all the values, because the first one value, that is for corresponding of n is equals to 0, x of small x of 0, this is for small x of 1, this is for small x of 2, x of 3, x of 4 as well as x of 5 here. So, we have put the, we will calculate. So, 336, 410 is equals to 12. So, the value of x naught at the position k is equals to 0, the DFT for the given sequence, that is equals to 12. That means, it will be the summation of the all individual sequence which is given into the any input sequence xn. Then next, for k is equals to 1, when we will go for it, then x naught summation of n is equals to 0 to 5 xn. So, already put the value in equation number 1 in equation number A. So, x naught So k is equals to 1. So it will become e raised to power of minus of j pi n by 3, because of the k value will be 1 here. So now we can further expand it like this. N ki value, for the value of n is equals to 0, x naught, then x is equals to 1, x1 e raised to power minus of j pi by 3, then x of 2 e raised to power minus of j pi 2 by 3 plus x3 e raised to power minus of j pi plus x4 e raised to power minus of j 4 pi by 3 plus x of 5 e raised to power minus of j 5 pi by 3 here. So we will sorry, it is a typing mistake here. This is for k is equals to 1, so that will become x of 1. So we will put all the values of x naught, x1, x2, x3, x4, x5 in this equation. So after putting the value, and we will put all the values of these factor e raised to power minus j pi by 3, e raised to power minus j 2 pi by 3, all these value we will evaluate. So we can calculate its value with the help of e raised to power of j theta minus j theta is equals to cos theta minus of j sin theta. So with the help of, we will calculate all the values and we will simplified it. So the final value after the calculation for the k is equals to 1, so the value will comes out minus of 1.5 minus of 1.5 plus j 2.598 here. Okay. After that, so this for two sequences we have evaluate. Next, now we will calculate for the value of k is equals to 1, we will done. So k is equals to 2. So it will be equals to x is equals to x of 2. Put the value in equation number A. So summation of n is equals to 0 to 5 xn e raised to power minus of j pi n k by 3. So k value is 2. So e raised to power minus j 2 pi n by 3 here. So this will become e raised to power minus j 2 pi n by 3. So similarly, now we can also evaluate it. Correspondingly, we will expand it. Similarly, we will expand it for the value of small n e raised x naught plus x1 e raised to power minus of j 2 pi by 3 x2 e raised to power minus of e raised to power minus of j 4 pi by 3 plus x3 e raised to power minus of j 2 pi x4. So 4 to the 8 here. So minus of j 8 pi by 3 plus x5 5 to the 10 minus j 10 pi by 3. So now again we will put all the values for here x0, x1, x2, x3, all these. So we will calculate it. The value for this k is equals to 2. The value will comes out equals to minus of 1.5 plus j 0.866. So for this value, for next one we will evaluate for k is equals to 3. The x of 3 from equation A we will get n is equals to 0 to 5 x of n e raised to power minus of j. From here we will evaluate. We will put the value here 3. We are solving. So when we put the value here 3, so 3 will be cancelled. So it will become e raised to power minus j n pi. J n pi. Now we will expand it. X naught x1 e raised to power minus j pi, x2 e raised to power minus j 2 pi, x raised to power 5 e raised to power minus of j 5 pi. So, when we will solve for this value, when we will evaluate the answer completely, when we will solve it, so the x of 3 we will get the value is equals to 0. The sequence will comes out. Similarly, when we will go for k is equals to 4 now, so this will become x4 from equation call to equation A. So, summation of n is equals to 0 to 5 x of n e raised to power, when we put the value here, what 4, we are 4. So, this will become e raised to power minus j 4 pi n by 3 e raised to power minus j 4 pi n by 3 here. So, now we will similarly the procedure will remain same. Now, we will expand this equation for the value of n x naught x1 e raised to power minus j 4 pi by 3 plus x2 e raised to power minus of 8 pi by 3, then x of 3 e raised to power 3 will cancel out, e raised to power minus of j 4 j, put the value of 3, so e raised to power minus of j 4 pi, then x4 e raised to power minus of 4 16, j of 5 will put 5 for the 20, so 20 pi by 3, then we will solve it. So, the value of this x of 4 will become comes out equals to minus of 1.5 minus of j 0.866. For the last one, k is equals to 5 we will evaluate from the equation A. The x5 will become n is equals to 0 to 5 x n e raised to power of minus 5 here, it will become minus j 5 pi n by 3 j 5 pi n by 3 here. So, the further it will expand x naught minus of j put 3 j 5 pi, after that x4 e raised to power 4 5 are 20 So, put the values of all these x naught to small x naught to x5, the answer we will get after evaluation we will get minus of 1.5 minus of j 2.598 here. So, all the values we have evaluated. So, the final of x of k, the value of this final of x of k, here we can now combinedly get for the value of this sequence 1 1 2 2 3 3 x n. So, the value will becomes out, we will evaluate x naught is equals to 12, then for x1 minus 1.5 minus of 1.5 plus j 2.598, then minus 1.5 plus j 0.866, this one, then 0, then for x4 we have evaluated here, that is minus 1.5 minus of j 0.866, and the last one sequence is minus of 1.5 minus j 2.598 minus j 2.598 here. So, this will be the corresponding DFT value for the given sequence of x of n here. So this is our final evaluated DFT. After that, the question has been asked that what is its computes phase and the amplitude magnitude spectrum. So for the evaluation of this, if any here the values are some complex values. So when we will go for the magnitude value, magnitude will be evaluated as if any complex number a plus jb. So the magnitude value is equals to under root of a square plus b square, and phase will be evaluated is equals to tan inverse of j upon b upon a here. So with the help of this, we can now evaluate, if we are able to evaluate its magnitude part. So the magnitude of this x of k is equals to, will comes out when we will do, that is the 12 comma under root of 1.5 square plus 2.598 square. When we will solve it, so it will comes out 2.999. Next one for this 1.5 square under root of 1.5 square plus 0.866 square, that is comes out equals to 1.732, then 0, then 2.999, then 1.732, then 2.999. So this is the magnitude spectrum for the given sequence x of n. Then phase we can evaluate. It can be written like that. This is for x's, then it will comes out 0, then tan inverse of b upon a. So tan inverse 0 b 0, 0 by 12 comes out 0. So tan 0 is equals to 0 value. And next one, minus of 5 pi by 3, that is 2.59 divided by minus 1.5. When we will solve it, so it comes out near about minus of pi by 3, then minus of pi by 6 for this 0.866 divided by 1.5, and this tan inverse will comes out, then 0. After that, pi by 6 and pi by 3 here. So in this way, we are able to evaluate any DFT for any for any infinite length discrete sequence. We will get its Fourier transform, which is itself is a discrete value, as well as it will present the periodic nature. The output will in the nature of the discrete with periodicity will be introduced here. So this is the regarding the DFT, and the procedure I have already explained in this video. So you are able to find the or calculate any DFT for the any given sequence in the if it is asked. So this is now from my side. So here I have taken the reference for the book Salivanan. So if you want to explore it more, then you can refer this book. So thank you and Jai.